This is Sung, the Principal and Director of Sky Academy, and in this episode what we're going to be doing is looking at the gradient. Now, gradient is just a way of measuring how steep a line is, or the slope of the line, okay? And the word we use is gradient, okay? So something that's totally flat like this will have a gradient of 0, yes? And as it gets steeper and steeper, the gradient becomes greater and greater, right? Until it reaches something like this, which is totally vertical. In other words, the gradient will become infinite, all right? This is an infinite gradient, and then it starts going negative when it starts tipping over the other way. So the other way that we can look at it is it's flat and it starts getting bigger and bigger, or gets smaller and smaller. So this is getting bigger and bigger as a gradient in the positive direction. This is getting bigger and bigger, or smaller and smaller in the negative direction, depending on how you look at it. So it's getting it's becoming more and more negative, is what I'm saying. And until it reaches this point, it reaches positive infinity if you keep going this way, or it reaches negative infinity if you keep going this way. Okay, but totally vertical is a gradient of infinity, and totally flat is a gradient of 0. And the way we work out these numbers is simply by using the formula, right? And the formula is this: gradient is equal to, right, get this, rise over run. Rise over run. And the way that we get the rise is the difference between, is this distance here. It's how much the line rises as we go from y1 to y2. Does that make sense? So that distance there is y2 minus y1. And if you want to know why this is y2 minus y1, look at the previous episode that we did on the distance formula, and I go into why this is y2 minus y1 in a bit more detail there. So just trust that this is y2 minus y1, and then this is the run, alright? So this is your rise, and this is your run, okay? So your rise is y2 minus y1, your run is x2 minus x1. And again, if you want to know why this is x2 minus x1, it's basically look at the video that I did on the distance formula. So the gradient is rise over run, which is the difference, and I use these triangles, but the triangle just means difference or change. So the change in y over the change in x, right? And the change in y would be y2 minus y1, and the change in x would be x2 minus x1, okay? So the gradient is given by rise over run. Now, I'm going to give you an example here. Alright, so we're going to find the gradient between 2 points, say 4 minus 3 and 2 minus 8. Okay, so the gradient would be equal to y2 minus y1 over x2 minus x1. And then what we have to do is we have to work out which one's which. This one would be x1, this one would be y1, this one would be x2, this one would be y2. And again, it doesn't really matter whether this is x2, y2 or this is x1, y1, alright? The gradient between 2 points would still be the same whether we chose one point to be the first and the other point to be the second, or if it was the other way around. The gradient would still be the same. So let's do that. So what we have is minus 8 minus negative 3, all on 2 minus 4. And the answer here would be, what is it? 5 minus 5 on minus 2, which is 5 on 2, or, yeah, 2.5. So our gradient would be 2.5. Does that make sense? So that is basically just the way that you would set it out, and it's very simple, the procedures that you go through as the midpoint, the distance, and the gradient. Okay, the first thing you have to do is write down the formula. Second thing you have to do is work out which coordinates and which points belong to which numbers. And then the third thing is substitute and then simplify, work out the answer. Okay, so I've summarized the three formulas that we've learned so far up on the board: midpoint, distance, and gradient. Okay, those three kind of all go together. So if you want to have a look, just have a look at them and become familiar with them. Alright, so thank you very much for watching. Hi, this is Sung again, and the reason why this episode is continuing the way it is because I want to tell you one more thing about the gradient. Okay, so we know that the gradient, which is rise over run, or the change in y over the change in x, expressed as a formula would be y2 minus y1 over x2 minus y1. The reason why this formula works is because you're looking at the slope or the angle where rise is over run, okay? But let me express this another way. The angle between the line and the x-axis, which we'll call theta, is also related to the gradient of the function, or the gradient of the straight line. And the reason why is because the rise over the run forms, with the equation of the straight line, a right angle triangle, right? Do you see that? And the rise over the run forms a right angle triangle where theta is the angle between the line and the x-axis, and the rise is equivalent to the opposite side of that right angle triangle, and the run is equivalent to the adjacent side of the right angle triangle. Now we also know that opposite over adjacent is equal to tan theta, yep, or tan theta is equal to opposite over adjacent. But we also know that opposite over adjacent is equal to the gradient of the function, rise over run, right? So what we can say is that tan theta is actually equal to the gradient of the straight line, okay, m. So I wanted to go through that with you and highlight that the gradient is equal to tan theta. Alright? Now, for those of you doing extension maths, we'll go into this in a little bit more detail and we'll extend that to angles between two lines. Okay? But if you're just doing advanced maths, just know that you might be required at times to use the fact that the gradient of a straight line is equal to the tan of the angle it makes with the x-axis. Thank you very much for watching.